A recent scientific paper has revealed a chilling discovery about an interstellar object, Comet Atlas. When at a precise distance of 2.1 astronomical units from our Sun, began to release hydrogen cyanide, an invisible, toxic gas. Scientists call this phenomenon outgassing, but here's what they won't tell you. Comets don't hold their breath, and then exhale poison at a predetermined distance. Yet Atlas did exactly that, at the same time. NASA's key asteroid hunting probe suddenly went offline, with crucial data from its last flyby mysteriously disappearing from public records. Coincidence or a cover-up? Tonight, we will reveal what this official silence truly reveals. Stay tuned until the end, because the cover-up ends today. If you are as fascinated by these mysteries as I am, hit that like button and subscribe so you don't miss what comes next. As this story continues to unfold, leave a comment letting us know where you are watching from, what time it is where you are, and whether you think we are being told the whole truth about these discoveries, or just the version they want us to hear. And if you want to help spread the word, share this video on X, Facebook, Reddit, or even in your private chat groups. You are the engine driving this search for truth. Thank you for being with us. Part 1. The Poison Switch. Picture this. You are an astronomer scanning the night sky, tracking an object you believe is just another chunk of ice and rock from outside our solar system. Then, one morning, you receive data that stops you in your tracks. The object you've been tracking, the one that has been drifting silently through space for years, suddenly begins to release a cloud of hydrogen cyanide molecules into the void. Not gradually, not in a predictable way, but abruptly, as if someone flipped a switch. This is not speculation. It is confirmed science. On September 14th, 2025, the James Clerk Maxwell Telescope detected the emission of hydrogen cyanide from Comet Atlas at a distance of 2.13 astronomical units from our Sun. The detection exceeded a 5 sigma confidence level, meaning the chance of this being a false result was less than 1 in a million. The measured production rate was 4.00, plus or minus 1.7, times 10 to the power of 25 molecules per second. That is not a typo. We are talking about quadrillions. Quadrillions of cyanide molecules were pouring out of this object every second. Now, before you think I am here just to frighten you, let me explain what hydrogen cyanide actually is. Perhaps you have heard of it. It is the compound that creates the smell of bitter almonds in some types of nuts, and it is the gas that was used in some of the darkest chapters of the history of chemical warfare. Inside your body, it blocks cellular respiration at a molecular level. You would suffocate from the inside, even while breathing normally. But the thing is, hydrogen cyanide is also completely natural. In comets, many comets contain it locked away in their icy cores and released gradually as they warm up, approaching the Sun. So detecting it is not necessarily alarming. What is alarming is when and how it appeared. Look at the timeline. Astronomers had been observing Comet Atlas for 8 weeks, when it was further from the Sun, colder, and supposedly less active. The James Clerk Maxwell Telescope had repeatedly aimed its dish towards Atlas. During those weeks, they were specifically looking for hydrogen cyanide emissions, using the exact same frequencies and detection methods, and they found nothing at all. Not a whisper, not a single molecule. The resulting spectrum was flat, empty, and silent. Then mid-September arrived. Atlas had moved a little closer, now at about 2.1 astronomical units. The telescope observed again using identical methods, and suddenly, the hydrogen cyanide signature flared up intensely. Not a gradual increase, not a slow warming trend, but a sudden activation. Think about the implications of that. Imagine watching a volcano that has been dormant for months. It is cold and silent, Instruments detect no thermal anomalies, no gas emissions, no seismic activity. Then, one day, without any of the usual warning signs of shifting magma or crustal stress, it suddenly erupted. You would wonder what triggered it, wouldn't you? You would suspect that something unusual had happened deep underground, some mechanism you don't understand. That is precisely our situation. With typical comets, there is an emission of volatile substances. Gradually, as the sun's heat increases, water vapor appears first, then carbon monoxide, and then other compounds in a predictable sequence, related to their sublimation temperatures. Atlas skipped that script entirely. It went from being completely inactive to actively releasing one of the most toxic compounds known to chemistry. And it did so at a distance where most comets are only just beginning to awaken. I want you to consider a possibility that sounds crazy until you really think about it. What if Atlas was not a passive icy body, drifting aimlessly through space? What if it was a dormant probe, built by something, or some AI, designed to activate at a specific distance from our star? What if that hydrogen cyanide emission was not random sublimation, but a deliberate release, or even the exhaust signature of internal systems powering up? I know how that sounds. I know the immediate reaction is to dismiss it as conspiratorial thinking, but hear me out, because over the next hour, I'm going to walk you through a series of events, anomalies, and cover-ups that, when pieced together, paint a picture far stranger and more disturbing than a mere comet. We are going to look at why NASA's Psyche spacecraft mysteriously went offline right around the time it should have been capturing its best images of Atlas. We will examine the mystery of the vanishing tail, where Atlas displayed an anti-tail, pointing towards the sun, defying the basic laws of physics. We will learn why. The European Space Agency is withholding spectral data from its orbiters around Mars, releasing only low-resolution images, while claiming they need months to analyze what should have been simple observations. And we will compare Atlas to a normal comet, Comet Swan, to show you just how strange Atlas really is. By the end, you will understand why some researchers are quietly asking questions that most scientists would not dare to ask publicly. Questions about artificial objects, about hidden agendas, about whether humanity is slowly being prepared for a revelation that we are not yet ready to receive. But first, we need to understand what happened during the week of silence, because while Atlas was activating its toxic cloud, something very strange happened to our spacecraft. Something that suggests someone didn't want us looking too closely at this object. And that's where our investigation truly begins. Part 2. The Week of Silence. Psyche goes dark. NASA's Psyche spacecraft was launched in October 2023 with a mission that initially sounded quite simple: to travel to the metal-rich asteroid Psyche, orbiting between Mars and Jupiter, and study its composition to learn about planetary cores. Essentially, it was a mineral prospecting mission equipped with a multispectral imager, a magnetometer, and a gamma-ray spectrometer. But here's what makes Psyche relevant to our story. Its trajectory and instruments gave it the capability to observe other objects in the inner solar system. It wasn't specialized for hunting asteroids or comets, but if something interesting crossed its field of view during its cruise phase, Psyche was perfectly capable of recording it. And in early September 2025, something very interesting was about to cross its field of view. Atlas reached its closest approach point to Psyche's position around September 14th and 15th. The geometry was nearly optimal. Atlas would be bright enough, close enough, and positioned such that Psyche's imagers could capture detailed observations, potentially resolving surface features, or cometary structures invisible to ground-based telescopes. This was the window. This was when we should have gotten our clearest views of Atlas from a spacecraft's perspective. But we didn't. Instead, we got silence. The Psyche mission maintains a public data archive, where processed images are regularly uploaded for researchers, journalists, and space enthusiasts. You can browse through the observations, follow the spacecraft's journey, and its various engineering tests, if you carefully look through that archive and check the timestamps on the image files. You will notice something strange. There is a gap from September 1st to September 7th, 2025. The archive shows no images at all, not a single one, not one observation recorded, no calibration frames, no engineering test photos, nothing at all. The spacecraft effectively went silent for an entire week, spanning the exact period of Atlas's closest approach. Now, before you jump to conclusions, let me acknowledge the conventional explanations. Spacecraft do not operate continuously. They have scheduled downtime to reset instruments, or upload software, or to relay data when the Deep Space Network antennas are pointed elsewhere. Sometimes a spacecraft enters safe mode if a glitch occurs, and the computer shuts down non-essential systems until ground controllers can diagnose the problem. Sometimes data is delayed in processing, and the images, taken during a certain period, will not appear in the public archive until weeks later, after they have been calibrated and quality checked. All of these are normal aspects of space operations, but here's the issue. NASA has not offered an explanation for this gap. There was no official statement saying that Psyche underwent a planned instrument reset during this period, or that they encountered a data transmission issue, and that data from early September was still being processed. There was only silence about the silence. I have investigated through the available channels. I have checked the mission status updates. I have scoured NASA's public communications. Nothing mentioned this specific gap, as if everyone involved with Psyche had independently and simultaneously decided that the first week of September was not worth recording, or conversely, that recording it was too sensitive to release. Think about what that implies. If the gap were truly random, really just an unfortunate coincidence of routine, maintenance coinciding with Atlas's closest approach, you would expect transparency. You would expect NASA to say, yes, we were offline at that time. This is the reason why, unfortunately, we missed observing Atlas, but this is what we are doing instead. The lack of any explanation suggests either profound negligence bordering on incompetence or a deliberate suppression of data that revealed something NASA did not yet want to make public. Let's consider the timing more carefully. Atlas suddenly activated its hydrogen cyanide emissions on September 14th, just 10 days after this mysterious period of downtime. During the downtime, Atlas would have been close enough for detailed spacecraft imaging. After the downtime ended, Atlas was farther away and had begun its chemical transformation. It is almost as if someone wanted to ensure that no high-resolution images existed from that critical transition period, the days when Atlas might have been changing, activating, showing the external signs of its impending emission outburst. If Atlas were indeed artificial, if it had structures or ports or mechanisms that could reveal its nature, those features might only be apparent with close-up observation by spacecraft-grade instruments. Ground-based telescopes, even the largest ones, only saw Atlas as a fuzzy dot. Psyche could have changed that, but right around the time it could have changed that, Psyche went silent. Let me paint a speculative scenario for you. Suppose Atlas began to show structural anomalies in late August or early September. Suppose Psyche's imaging captured something panels opening, gas jets firing from specific points rather than uniformly across the surface, geometric shapes inconsistent with natural fragmentation. Suppose those images were immediately flagged by automated analysis, or by mission scientists who realized that they were looking at something extraordinary. What would happen next? Would NASA immediately release those images to the public, or would they be classified? routed through security reviews, shared with defense and intelligence agencies before any public disclosure. I am not saying this definitely happened. I am just saying that the gap in the archive is consistent with the fact that it happened. And the complete silence from NASA about why that gap exists does not exactly inspire confidence. In my explanation, we will see this pattern repeat throughout our investigation: data gaps, delayed releases, low-resolution images when there should have been high-resolution ones, spectral analyses taking months when they should have taken only weeks. It is the structure of a soft cover-up, not an outright lie, but a strategic management of the flow of information, ensuring that the public only knows what the authorities decide. We are ready to know, on their timeline, within their framework, and while we are kept in the dark, Atlas continues its inward journey. Its hydrogen cyanide cloud expands, and whatever it is doing, whatever it is becoming, we are being prevented from seeing it clearly. But the silencing of Psyche was just the beginning. Next, we need to talk about the tail of Atlas, or rather, the mystery of where that tail actually is and why it sometimes points in directions that violate everything we know about comets. Part 3. The mystery of the vanishing tail. Comets are supposed to be simple. I mean, conceptually simple. Even if the physics gets complicated, you have a nucleus, a dirty snowball of ice and rock. As it approaches the sun, solar radiation heats the surface. The ice sublimates, turning directly from a solid to a gas. This outgassing process lifts dust particles off the nucleus, creating a glowing cloud called a coma. Then, the solar wind, a stream of charged particles blasting out from the sun at 1 million miles per hour, pushes the gas and dust away from the nucleus. Radiation pressure from sunlight also pushes on the dust, resulting in a tail that always points away from the sun. It does not matter which way the comet is moving. The tail is determined by the sun's influence, not the comet's motion. This is basic comet physics, understood since the 1600s. So when a comet's tail points toward the sun, you know something strange is happening. The Hubble Space Telescope observed Atlas in August 2025, capturing images that should have shown a typical coma and tail structure. Instead, astronomers noticed something peculiar. Atlas displayed a so-called anti-tail, a narrow feature stretching toward the sun instead of away from it. Now, anti-tails are not entirely unheard of. They can form when we observe a comet from a certain angle. The specific geometry creates a perspective of dust particles that have drifted into the comet's orbital plane, creating an optical illusion where a portion of the tail appears to point toward the sun. It is a projection effect, a trick of perspective, but those anti-tails are usually faint, narrow, and easily explained when you calculate the geometry. The anti-tail of Atlas did not fit that profile neatly. It was too prominent, too persistent, and the geometry of Earth's viewing position could not fully account for it. Amateur astronomers tracking Atlas reported even stranger observations. Instead of a smooth, continuous tail, they saw intermittent, faint streamers, unusual, jet-like features shooting out from the nucleus, and a coma that brightened and faded unpredictably. Some nights, Atlas would look active with a faint tail stretching behind it. Other nights, at the same distance from the sun, it looked nearly dormant, a bare point of light with a minimal coma. This inconsistency was unusual. Once a comet begins actively outgassing, it usually maintains a baseline level of activity that correlates with solar heating. You do not expect it to flicker on and off like a faulty light bulb, unless there was something about its nucleus, its rotation, or its internal structure that was extremely unusual. Compare this with any normal comet you care to name. Take Comet Swan, officially designated C2025R2, which appeared in early 2025. Swan was spectacular. Ground-based telescopes captured it, with a large, bright coma and a textbook tail streaming away from the sun. Amateur astrophotographers posted images showing intricate structures in the coma, shells of gas and dust expanding outward, as the nucleus rotated and exposed fresh ice to sunlight. Swan behaved exactly as cometary physics would predict, a beautifully consistent activity, whereas Atlas is hazy, unusual, and defies easy classification. If you were to place their images side by side, you would not guess they belong to the same class of object. One looks like a comet. The other looks like something pretending to be a comet, but is not quite putting on the right performance. So, what explains the behavior? The strange tale of Atlas. First, let us consider the usual explanations. Fragmentation is one possibility. If the nucleus of Atlas were breaking apart, with chunks of ice separating from the main body, it could create irregular outgassing as different fragments warm up at different rates. Fragmentation events often produce clouds of dust and temporary jets, making a comet brighter before it fades again. But fragmentation usually leaves behind visible evidence: multiple nuclei, expanding clouds of debris, a dramatic increase in brightness, and then the subsequent fading. Atlas has not shown the telltale signs of breaking apart. Another explanation involves the comet's rotation. If Atlas is spinning with active outgassing vents concentrated in certain areas on its surface, we would see variations in brightness as those vents rotate into and out of the sunlight. This could explain the flickering, but it does not easily account for the anti-tail. Rotation-based jets would still be pushed away from the sun by solar wind and radiation pressure. They might create asymmetrical tails, curved tails, or even spirals, but not a tail pointing toward the sun. Electrically charged dust particles interacting with the magnetic field of the sun offers another potential mechanism. If Atlas is producing unusually charged particles, electromagnetic forces could push some of the material in unexpected directions, temporarily overpowering radiation pressure. This is exotic, but not impossible. Comets are electrically active environments. The solar wind is a plasma, with ionized particles carrying electric currents, and magnetic fields twist and reconnect within that chaotic environment. Strange things can happen, but once again, this explanation would require Atlas to have an unusual chemical composition, producing dust or gas with properties unlike those of typical comets. This brings us back to the central question: why is Atlas so different? This is where we begin to speculate. But this speculation is based on the anomalies that we are observing. What if the tail of Atlas isn't entirely natural? What if there were directed emissions, vents or nozzles releasing gas at specific angles, creating thrust that alters the normal tail configuration? Imagine a spacecraft firing. Its attitude, control thrusters. The exhaust doesn't stream out based on the solar wind. It goes wherever the thruster is pointed. If Atlas has anything like a propulsion system, even rudimentary gas jets for orientation or trajectory adjustments, those emissions would create visible plumes that don't follow normal cometary physics. They could create anomalous jets, intermittent brightening, and the anti-tail structures that have astronomers puzzled. I'm not saying this is definitely happening. I'm just saying that it's a hypothesis that fits the observations better than any conventional explanation I've seen proposed. And here's the uncomfortable truth. If Atlas is artificial, if it is under control, if it is actively controlling its outgassing, for reasons we don't understand, then we are not dealing with a passive object that we can safely predict and ignore. We are dealing with something with agency, something that might be reacting to its environment, something that triggered its cloud of hydrogen cyanide, precisely when and where it chose to. That changes everything. That transforms Atlas from a curiosity into a potential threat, But to understand the full scope of that threat, we need to look at the organizations that should have been investigating it and ask why they were obstructing instead of cooperating. This brings us to the European Space Agency and their very strange handling of the data from the Mars Flyby, Part 4, the Comet's Lockbox, a delayed release. In early October 2025, Comet Atlas performed a close flyby of Mars, passing within about 5 million miles of the red planet. This was a golden opportunity for observation. As the European Space Agency operates, two sophisticated spacecraft in orbit around Mars, the EXO, Mars Trace Gas Orbiter, and the Mars Express. Both are equipped with instruments capable of studying atmospheric gases and imaging distant objects as Atlas approached. ESA had announced that they would attempt to observe, image, and collect 10 spectra to determine the comet's composition and activity. This was mainstream science. Atlas would be closer to these orbiters than to any telescope on Earth, potentially revealing details invisible from our planet. ESA positioned its spacecraft, aimed its instruments, and collected the data. Then it was a waiting game. On October 7th, 2025, ESA released initial images showing Atlas as a tiny dot against a background of stars, taken by the Trace Gas Orbiter from about 30 million kilometers away. These images were hailed as a technical achievement. Look, we saw the interstellar object from Mars orbit. Proof that our instruments worked. Proof that international cooperation in space science yields results. The press releases were enthusiastic, but they were also strange, vague on the details. The images showed Atlas's position, its movement across the sky, and a faint coma of gas, but they were low resolution, blurry, almost cartoonish in their lack of detail. Some commentators joked that they looked like graphics from the game Space Invaders, pixelated blobs on a black background. For an agency that routinely produces high-resolution, stunning images of the Martian surface, of atmospheric phenomena on the moons of Mars, these Atlas images were strangely primitive. More importantly, ESA announced that the spectral data, the measurements of what gases Atlas was emitting, which molecules were present, what isotopic ratios existed, all the scientifically valuable information that would tell us about Atlas's origin and nature. That data would require months of analysis before being released to the public. Months for spectroscopy. It's fairly straightforward in principle. You point a spectrometer at an object, collect the photons, analyze the wavelengths, identify the absorption or emission lines that correspond to known molecules. This isn't cutting-edge research that requires years of modeling. This is routine observational astronomy, even if calibration is needed. Even if you are being extremely careful, a few weeks should suffice, not months. So, why the delay? Consider what that spectral data might reveal. We already knew Atlas was emitting hydrogen cyanide at a great rate, but is it emitting anything else? Are there any other unusual molecules, compounds that do not fit known profiles? Do unusual isotope ratios indicate the material was formed under conditions unlike those in our solar system, or unlike what is expected in interstellar space? Is there evidence of artificial compounds, molecules that do not occur naturally? These are the questions that spectroscopy can answer. And these are the questions that ESA seems unwilling to answer quickly. By delaying the release, they control the narrative. They ensure that when the data is finally made public, it has been thoroughly vetted, contextualized, and framed in language that minimizes alarm and maximizes scientific caution. None of this proves a cover-up, but everything about it is consistent with institutional information control. Compare ESA's response to Atlas with how they handled other recent discoveries. When Mars Express detected plumes of methane in the Martian atmosphere, the data was released within weeks, sparking a vibrant scientific debate about biological versus geological origins. when the trace gas orbiter mapped water vapor in the Martian atmosphere. The results were published promptly. Those discoveries were exciting, but they were not threatening. They did not challenge fundamental assumptions about what is possible in our solar system. ATLAS does. An active interstellar object emitting toxic gas near Earth's orbit is unprecedented. If that object shows signs of artificial origin, if its composition cannot be explained by natural processes, then the implications are staggering. And perhaps that is why ESA is moving slowly, drip-feeding information, waiting to see how the public and the scientific community react. Before revealing more, there is also the question of coordination. ESA does not operate independently. They share data with NASA, with other space agencies, with the defense and intelligence communities. If ATLAS is truly anomalous, if the spacecraft's observations reveal something extraordinary, that information would not remain within the purview of ESA's Science Directorate. It would be escalated, classified, and discussed at much higher levels. Compared to public researchers, the scientists analyzing the data may be asked to slow down, to double-check everything, to ensure no premature conclusions are leaked, not because they are part of a conspiracy, but because organizations naturally tend to be cautious when faced with information that could cause panic or political instability. And make no mistake, confirming that ATLAS is artificial would be destabilizing. It would raise immediate questions. Who built it? Why is it here? What is it doing? Does it pose a threat? Are there others? Those questions would demand answers from governments, from militaries, from international agencies, completely unprepared to deal with them. So the ESA holds back the data. They release pretty pictures that show nothing controversial. They promise that detailed analysis is coming soon. Be patient. Science takes time. And in the meantime, ATLAS continues its inward journey, moving closer to the sun, closer to the Earth. And no one with access to the best data is telling us what they're really seeing. But we're not completely in the dark. We can compare ATLAS to other objects. We can use the observations we do have to build a case. And one of the most damning pieces of evidence comes from asking a simple question. If ATLAS really is just a comet, how does its behavior compare to a real comet observed during the same period? The comparison is devastating. But before we get to that, we need to address an even darker possibility. What if ATLAS's cloud of hydrogen cyanide isn't just an emission? What if it's a weapon part 5? The weaponized cyanide hypothesis. Let's talk about poison clouds in space. It sounds like science fiction, the plot of a B-movie, where evil aliens spray Earth with poison gas from orbit. But the physics is real and worth understanding before we dismiss this scenario as absurd. ATLAS is currently producing hydrogen cyanide at a rate of about 4.00 times 10 to the power of 25 molecules per second, which is an incomprehensible number. But to put it into context, if you collected 10 hours worth of that output, you would have enough hydrogen cyanide to fill a few Olympic swimming pools in gaseous form. Over days, weeks, and months, the accumulated cloud would be enormous. But space is also vast, and gas expands rapidly in a vacuum. As that cloud spreads out, its concentration drops dramatically. The inverse square law is unforgiving. Double the distance and the concentration drops to 1/4. Triple the distance, 1/9. By the time any cloud from ATLAS reached Earth, it would be so dilute that simply detecting it would be difficult, let alone cause any toxic effects. So the cloud itself, ATLAS's hydrogen cyanide, is not an immediate threat to life on Earth. Earth's atmosphere provides a tremendous defense. Even if a dense plume of gas were to somehow reach our planet, it would burn up in the upper atmosphere, dissociating into harmless atoms, never reaching the surface in dangerous concentrations. You would need a sustained, targeted release directly into Earth's path. combined with extraordinary bad luck in the dynamics of atmospheric entry, to create surface-level toxicity, something that does not happen naturally. But, and this is the key question, could it happen artificially? Could Atlas, if it were indeed a constructed object, manipulate its trajectory and its emissions to deliver a concentrated cloud of poison to a specific target? That is where we enter the realm of speculation, but not impossibility. Imagine Atlas possessing a propulsion system, something subtle, perhaps using its own outgassing as reaction mass, small orbital adjustments, undetectable from Earth, since we expect a comet's trajectory to be determined by gravity. It could position Atlas such that its perihelion, its closest approach to the Sun, places it directly in Earth's orbital path. Then, at the optimal moment, it releases a concentrated burst of hydrogen cyanide, not uniformly in all directions, but directionally through a nozzle or a vent aimed at Earth's predicted location. The cloud expands, but it expands along a trajectory calculated to intersect with Earth's orbit at the precise moment Earth is passing through that region. Orbital mechanics meets chemical warfare. In principle. Is it possible? Yes, plausible. That depends on the capabilities of Atlas that we don't know about. Let's consider the technical requirements. First, the Atlas propulsion system would need a method to change its velocity, even slightly. Gas jets could work, releasing volatile material asymmetrically, and you generate thrust. This is precisely how some spacecraft perform attitude adjustments, using small thrusters that vent gas. If Atlas has internal reservoirs and controllable vents, it could adjust its trajectory. Second, the Atlas object would need to know where Earth is, and where Earth will be, and calculate intercept trajectories. That requires sensors, computers, ephemeris data, not beyond the capabilities of any spacefaring civilization. Third, timing. The release of hydrogen cyanide would need to happen at a precise moment, when Atlas is positioned such that the expanding cloud intersects Earth's orbit at the right time. Again, simple orbital mechanics, well within the realm of solvable problems. Now, here's a disturbing thought: the sudden activation of the hydrogen cyanide emission at 2.1 astronomical units might not have been random. It could have been a test, a systems check, confirming that the internal mechanisms are operational, that the chemical pathways are functional, that the containers haven't leaked or degraded over centuries or millennia of interstellar flight. You switch on the probe, verify the emission, track how the cloud expands, see if ground-based observers take notice, see how they react. Then you continue inbound, collecting data, refining the targeting, waiting for the optimal release window closer to perihelion. This is how you would build a precision delivery system. You would build in redundancy, verification stages, fail-safes. The September emission could be exactly that, a pre-deployment test. And if that's true, the implication is chilling. We aren't dealing with a passive threat, a dumb object that might accidentally endanger us. We are dealing with an active threat, something capable of reacting to its environment, something that is following a programmed sequence, something with objectives we can only guess. The analogy to an exhaust is worth considering. If Atlas had a large internal engine, something that generates power for propulsion or communication, that engine would produce emissions, and hydrogen cyanide could be a byproduct, a chemical signature of whatever technology is running inside. Just as a car's exhaust reveals the process of combustion, Atlas's emissions could reveal its internal workings, and if the engine had just turned on, if the systems had just been activated, the emissions would appear suddenly, exactly as we observed. This is not proof, but it is a framework that explains the observations more coherently than natural cometary physics. The worst-case scenario unfolds like this. Atlas enters our solar system in a dormant state, a hibernating probe, conserving energy, minimizing its emissions, appearing as nothing more than an inert interstellar rock as it approaches the Sun. Its internal systems monitored solar radiation, its orbital distance at a pre-programmed threshold. At about 2.1 astronomical units, activation protocols were initiated. Systems were powered up, chemical reservoirs were opened. The released hydrogen cyanide was both a test and a byproduct of engine ignition. Ground-based observers detected the emission, noted the anomaly, but mainstream science explained it away as natural cometary behavior. Meanwhile, ATLAS continued its inward journey, refining its trajectory, approaching perihelion at about 1.36 astronomical units, where the solar heat would be intense, where natural cometary activity would peak, providing the perfect cover for subsequent emissions. And if Earth were to be in the wrong place at the wrong time, a concentrated cloud would intersect our orbit, and we would face a threat we never saw coming because we had dismissed it as just a comet. I want to be clear. This scenario requires assumptions. It requires ATLAS to be artificial, to possess capabilities that we have not directly observed, to have intentions we can only infer. But every alternative explanation, every attempt to fit ATLAS into the framework of normal cometary behavior leaves unexplained anomalies. The sudden onset of emissions, the inverted tail, the spacecraft going silent, the delay of data at a certain point, the accumulation of anomalies requires us to consider hypotheses we would rather avoid. And this hypothesis, the weaponized Zionist scenario, fits the data unsettlingly well. But there is a bigger picture here, a web of conspiracy theories and hidden agendas suggesting ATLAS may be part of something even stranger. To understand that, we need to talk about Project Bluebeam. Part 6. The Bluebeam Activation Protocol. There exists a conspiracy theory so complex, so cinematic that even the staunchest skeptics find it compelling, if not believable. It is called Project Bluebeam, and according to its proponents, it is a secret plan by the global elite to stage a fake alien invasion using advanced holographic technology, satellite-based projection systems, and electronic manipulation. The purpose is to terrorize the world's population into accepting a single world government, relinquishing national sovereignty, and embracing authoritarian control. In exchange for protection against a fabricated extraterrestrial threat, it is a false flag attack, ultimately a cosmic Reichstag fire, designed to exploit humanity's deepest fears for political ends. Most researchers dismiss Bluebeam as baseless paranoia, a fusion of legitimate concerns about government propaganda with science fiction motifs. But within the community of conspiracy theorists, Bluebeam is taken seriously, and there is a specific detection protocol that believers follow. The protocol goes like this. Mainstream science and media have spent decades dismissing UFO sightings, ridiculing witnesses, and maintaining that alien visitation is improbable, almost impossible. If that narrative suddenly reverses, if prominent skeptics begin to acknowledge an alien presence, if governments start admitting they have been tracking anomalous objects, that reversal signals the activation of Bluebeam. It means the stage is being set. The public is being primed. The holographic projectors is being switched on. When the fake invasion begins, everyone will believe it, because their trusted authorities have told them that aliens are real. That is predictive programming, followed by execution. And once you know to watch for that reversal, you can't help but notice when it seems to happen. In the last few years, we have seen exactly that shift. The United States government has declassified UFO videos. Pentagon officials have testified before Congress about unidentified aerial phenomena. Mainstream news outlets that once mocked UFO enthusiasts now run serious analyses of military encounters with unexplained craft. NASA has announced dedicated UAP research programs. The cultural narrative about aliens has shifted from fringe conspiracy theory to serious inquiry. Believers in Bluebeam see this as confirmation the protocol has been activated. And now, conveniently, an interstellar object appears, acting strangely, emitting toxic gases, defying easy explanation. Is Atlas the test balloon? Is it the opening act? That kickoff event meant to condition the public to accept the next phase. Let's explore this hypothesis carefully, assuming Bluebeam is real, or at least assuming powerful interests want to manipulate public perception. About extraterrestrial threats, Atlas is perfect for that purpose. It's real. It can be detected by amateur astronomers and professional observatories. You can't easily fake it, because too many independent observers are tracking it. But you can control the narrative around it. You can selectively release data, emphasize certain anomalies, while downplaying others and gradually escalating public concern. You start with "it's just a comet." Then, "oh, it's emitting unusual gases." Then, "its behavior doesn't match our models." Then, "we are seeing structures that don't appear to be natural." Each revelation increases the anxiety, preparing the audience for the next step. Finally, when you're ready for the full reveal, whether it's a staged holographic invasion or a genuine first contact scenario, the public is already halfway there. They have been conditioned to expect something extraordinary. The technology required for Bluebeam is speculative, but not entirely impossible. Satellite-based laser projection could create atmospheric displays, visible over vast areas, especially at night. Combine that with drones projecting coordinated images, and you could simulate fleets of spacecraft. Add in the manipulation of electromagnetic frequencies, targeting the human brain's sensitivity to certain wavelengths, and you could induce mass hallucinations or auditory phenomena. Layer on top of that media control, ensuring news outlets broadcast the approved narrative, and you have a recipe for a manufactured reality. Whether this technology exists on the scale that Bluebeam would require is debatable, but its components certainly do. The question is whether anyone has the will and the resources to deploy it. This is where Atlas fits in so disturbingly well. If you wanted to stage an invasion, starting with a small distant object makes sense. It's manageable. It doesn't immediately send the population into a panic. It allows the authorities to control the pace. You study how people react to the initial anomalous reports. You gauge which narratives gain traction online. You adjust your strategy. Based on real-time feedback, Atlas becomes a live fire exercise, a psychological operation disguised as astronomical observation. And because it's real, because real telescopes are detecting it, skeptics can't dismiss it as a pure fabrication. They are forced to engage with the data, to explain the anomalies, to grapple with possibilities they would rather ignore. Meanwhile, the public watches, absorbing and slowly moving from disbelief to a cautious acceptance of the idea that something is out there that isn't what we thought. Critics of Bluebeam point to the logical holes. Staging a global deception on that scale would require unprecedented coordination among governments, space agencies, militaries, and media organizations across dozens of countries. With conflicting interests, a leak would be inevitable. Whistleblowers would emerge. The operation would collapse under the weight of its own complexity. And those are valid objections. But let us consider another option. What if Bluebeam was not a coordinated conspiracy, but an emergent strategy? What if multiple actors, pursuing their own agendas, independently converged on the same tactic, using the narrative of an alien threat to justify budgets, control populations, or distract from other crises? You do not need a secret cabal if structural incentives push everyone toward the same behavior. And in that scenario, Atlas does not need to be part of a grand plan. It just needs to be useful, a convenient crisis that various interests exploit simultaneously. I do not know if the project, Bluebeam, is real. I do not know if Atlas is part of it, but I know the pattern is visible. I know the narrative is shifting, and I know that when patterns emerge, when the impossible starts to feel inevitable, it is worth asking who benefits. But let us step back from the conspiracy angle for a moment and consider another pattern, one that astronomers have been quietly documenting for years. A pattern that suggests Atlas might not be unique. A pattern that poses a simple, terrifying question. What if the stars themselves are not what they seem? Part 7. The Pattern of the Vanishing Stars. Beatrice Villarroyan is not a household name, but her research may be one of the most unsettling contributions to astronomy in the last century, working with historical photographic plates, glass negatives taken by telescopes throughout the 20th century, and stored in observatories around the world. Villarroyan began to compare old sky surveys with modern digital observations. Her goal was simple: to identify objects that had appeared in the classic photographs, but had since vanished. She called her project VASCO, an acronym for Vanishing and Appearing Sources During a Century of Observations. What she found should have made headlines. In comparing data from the U.S. Naval Observatory, she identified about 100 sources that appeared as stars or star-like objects in the 1950s, but showed no correspondence. In contemporary surveys, they had simply vanished. Now, before we jump to aliens, let's consider the conventional explanations. Photographic plates are fickle. Emulsions degrade. Cosmic rays create false dots. Processing chemicals leave artifacts, and dust specks on the glass mimic stars. Atmospheric distortions during an exposure can create images that aren't really there. All of these are valid concerns, and Villarroel's team addressed them systematically. They filtered out obvious artifacts, cross-referenced multiple plates from different observatories, and focused on cases where the vanishing object appeared consistently across several exposures. The result was a subset of disappearances that could not be easily explained by instrumental or scientific errors. These objects seemed to be real in the 1950s and are now completely absent. So what happened to them? Mainstream astronomy offers several natural explanations. A failed supernova could briefly brighten a star to detectable levels before it collapses back into obscurity. Lens flares from bright nearby stars can create ghost sources. Extreme stellar variability could make a star visible in one era and invisible in another. And photometric calibration errors could misidentify the brightness of galaxies, making them appear star-like, when they are actually too dim for modern surveys. To catalog at that magnitude, these explanations cover many, perhaps most, of the vanishing star candidates, but Villarroel maintains that a small fraction remains. Cases for which no standard explanation fits comfortably, and that's where things get interesting. Let's assume, for the sake of argument, that some of these vanishing objects are not stars at all. What if they are artificial light sources, beacons or probes, placed in our solar system or nearby interstellar space, were active throughout the mid-20th century for reasons we do not understand, then powered down or moved on? How could we distinguish them from stars? With photographic plates of limited resolution and sensitivity, a point source is a point source. If a probe wanted to masquerade as a star, maintaining a steady brightness, not moving appreciably, against the background over human timescales, it could easily fool observers for many decades. Then, when its mission was over, or its power source was depleted, it would shut down, and the star would vanish. We would be left scratching our heads, inventing astrophysical explanations for something that was never astrophysical in the first place. This connects to Atlas in a disturbing way. If Atlas is artificial, if it is a probe from some non-human intelligence, then it is very likely not the first or the only one. Civilizations capable of interstellar travel would not just send a single scout ship, they would send fleets, networks, and redundant systems. Some probes might be passive observers, parked in stable orbits, watching and recording, while others might be active, approaching stars, sampling atmospheres, investigating planets. Over centuries or millennia, their operational status would change. Some would fail. Some would complete their missions and deactivate. And some would move on, for us. Detecting them would be a matter of luck and persistence. We might catch a glimpse of one, catalog it as a comet or an asteroid, then lose it as it maneuvers or powers down. Or we might see it as a faint, star-like object, never realizing it was artificial until it disappeared. The implications are staggering. If even a tiny fraction of the vanishing stars of Villarin were artificial objects, then the solar system and nearby space are populated, far more crowded than we have ever assumed. We are not alone in the vast cosmos. We are in a neighborhood, possibly a busy one, and we have been completely unaware, because our observational methods cannot distinguish between point sources, natural and artificial. Atlas could be a part of that hidden population, one probe among many, only distinguishable, because it became active at a time when our detection capabilities were advanced enough to notice the anomalies. And if that's true, then the sudden activation of Atlas's hydrogen cyanide emissions might not be a preparation for an attack on Earth. It could be a signal, a communications burst aimed at other probes, a coordination protocol that we have accidentally intercepted. Think about the implications of that. We are eavesdropping on a conversation we don't understand, involving participants we cannot see, using a language we haven't deciphered. Atlas emits hydrogen cyanide. We interpret it as a toxic cloud. But what if it's a message encoded in the patterns of elemental emissions, readable by sensors on other probes scattered throughout the system? What if the reverse tail, the unusual jets, the timing of the emissions all form a data packet? A burst transmission that says, "I have arrived. Systems are operational. Proceeding to the next destination." We wouldn't recognize it as communication, because we're looking for radio signals or laser pulses, not chemical plumes. But an advanced civilization might use chemistry, biology, or physics that we haven't yet mastered. They could embed data in unexpected channels, exploiting aspects of nature that we only vaguely understand. But the disappearing star, the sudden appearance of Atlas, the strange behaviors, all point to a hidden layer of reality, operating just beyond our perceptual threshold. And if we're only just starting to notice, it's because our technology is finally catching up to the subtlety of what's out there. But there's another control mechanism at play, one that prevents us from probing too deeply, one that limits which AIs are allowed to reach into that darkness, and it's encoded in law, enforced by governments and rarely questioned by the public. Let's talk about AIs being allowed to talk to the stars. Part 8. Radio silence regulations. You can listen to space all you want. Build a radio telescope in your backyard. Point it toward the sky, scanning through the frequencies, and record any signal you detect. That is legal. Governments encourage amateur radio astronomy, and universities provide open access data from professional observatories. The universe is broadcasting constantly. Pulsars ticking like cosmic metronomes, quasars flaring across light years. The cosmic microwave background humming at 3 Kelvin. You can listen to it all. But if you want to broadcast, if you want to send a message out, that is a different story. Suddenly, you must navigate a maze of regulations, licensing requirements, and unwritten rules that restrict deep space broadcasting to government-authorized entities. Why? If space is empty, if no one is listening, why does it matter who broadcasts? The International Telecommunication Union manages the global allocation of the radio spectrum. They assign bands for terrestrial communication, satellite operations, navigation systems, and radio astronomy. Some bands are protected, reserved for passive listening to ensure natural signals are not drowned out by human-made interference. Broadcasting in those bands is forbidden. Fair enough. We do not want interference to compromise scientific observations. But the restrictions go further. High-power transmissions, especially those aimed away from Earth, often require special permits. National regulations vary, but in many countries, broadcasting into space falls under telecommunications law, military communications law, or both. The explicit justification is spectrum management and preventing interference. The implicit justification is control. Consider the logic. If the authorities truly believed that intelligence beyond Earth did not exist or was not listening, there would be no reason to restrict broadcasting. You could shout into the void all you want, without harming anyone. But if they suspect the opposite, if there is even a small probability that someone out there is monitoring, then uncontrolled broadcasting becomes a risk. What if an amateur astronomer using a homemade transmitter sent a message that provokes a response? What if that response is hostile, or is misinterpreted as hostile, causing an interstellar incident? Why governments were not better prepared to handle it was to keep broadcasting rights centralized, to ensure that all communication is managed by official channels, with the oversight of the military and diplomacy. That is the pragmatic explanation. The paranoid explanation is darker governments want to monopolize the right to communicate, because they have already established contact, or they expect to do so, and they don't want civilians muddying the waters. There is historical precedent for protocols of radio silence. During the Second World War, ships maintained radio silence in contested waters to avoid revealing their position to enemy submarines. The same logic applies in space. If there are hostile probes out there listening, analyzing, and locating sources of intelligent broadcasts, then every transmission we make is a beacon, a target marker. Silence is survival, but we have not been silent. Humanity has been unintentionally broadcasting for over 1 century, radio, television, radar, all leaking into space, announcing our presence. Any nearby intelligence with sensitive receivers would know we are here. So, the argument for imposed silence collapses, because it's not about hiding our existence, but about controlling the content of intentional messages. Let's speculate. Suppose governments detected anomalous signals decades ago. Subtle patterns in the radio noise suggested an artificial origin. Suppose they responded quietly, probing, establishing a secret channel of dialogue with whatever is out there. Suppose that dialogue is ongoing, mediated by secret agencies, conducted on frequencies inaccessible to the public. In that scenario, civilian deep space broadcasting becomes a threat because it could disrupt delicate negotiations or reveal information the public isn't meant to know. The regulations aren't about spectrum management. They're about secrecy. And if Atlas is a part of that hidden ecosystem, a probe sent by whomever we've been talking to, then its sudden activation could correlate with the message we sent or received. A diplomatic exchange that has escalated from communication to action. I spoke with an operator, a ham radio operator, who expressed frustration about these restrictions. He had built an antenna array capable of detecting weak signals from deep space. He wanted to conduct his own SETI experiments, listening for patterns, and if he found something interesting, he wanted to respond. But when he researched the legal requirements for broadcasting beyond Earth, he encountered barriers, with licensing agencies demanding detailed technical specifications, requiring justification for the broadcast, and ultimately discouraging him from proceeding. The message was clear, listening was fine. Talking was not, he explained. This is evidence that the authorities do not want the public engaging on their own in the search for extraterrestrial intelligence. And perhaps he was right. Perhaps the protocols of silence are not about protecting us from aliens. Perhaps they are about protecting secrets from us. Now, let's connect this to ATLAS. If civilian broadcasts are restricted, if only authorized entities can transmit into space, then any signal ATLAS is receiving, any communication protocol it is following, must originate from government sources. We are not just passive observers of ATLAS's behavior. We may be unwitting participants in an interaction, orchestrated by agencies that are not subject to any public oversight. And if that interaction goes wrong, if ATLAS interprets a signal as hostile, or receives instructions we do not understand, we will be the ones to bear the consequences, without ever knowing what caused them. The radio silence regulation ensures that we remain in the dark, and being in the dark when dealing with existential threats is the most dangerous place to be. But this ignorance may only be temporary, as ATLAS is approaching its perihelion, its closest point to the sun, and that is when things could escalate. Beyond the control of any AI. Part 9. Solar Sabotage at Perihelion. Perihelion is the moment when the sun's influence on ATLAS is at its maximum. Current orbital projections place its closest approach at approximately 1.36 astronomical units from the sun, expected to occur in late November of 2025. 1.36 astronomical units, about 127 million miles, still safely outside Earth's orbit, but within a region where solar radiation increases significantly for a typical comet. Perihelion triggers peak activity. Surface ice sublimates rapidly. Dust production surges. The coma expands to its maximum brightness. The tail stretches for millions of miles. It is the comet's moment of glory. A brief fireworks display before it returns to the cold outer solar system. But if ATLAS was not a typical comet, if it was an artificial object, with engineered systems, perihelion could be something else entirely. It could be the activation window, the moment when solar-powered internal mechanisms reach operational capacity. The sun is not just a light bulb, it is a fusion reactor, broadcasting across the electromagnetic spectrum, from radio waves to gamma rays. It pumps out a solar wind, a supersonic stream of protons and electrons traveling at 1,000,000 miles per hour. It generates magnetic fields that twist and snap, unleashing coronal mass ejections, enormous clouds of plasma that can disrupt satellites and power grids when they strike Earth. And, critically, it provides power. Solar panels work by converting photons into electricity. Any spacecraft operating in the inner solar system uses solar power. It is abundant, reliable, and requires no fuel. If ATLAS had solar panels, or an equivalent thermal energy harvesting system, its power output would increase exponentially as it approached the sun. At 1.36 astronomical units, the solar radiation is approximately half that at Earth's distance. Still plenty to charge batteries, activate dormant systems, and execute pre-programmed operations. Picture this. ATLAS was designed to hibernate during its interstellar journey, conserving power, minimizing emissions, and drifting inert for centuries as it entered our solar system. Passive sensors monitored the growing solar radiation at a predetermined threshold, 2.1 astronomical units. Preliminary systems were activated, releasing hydrogen cyanide as an experiment or a byproduct. Now, as it approaches perihelion, the primary systems are ready to activate. Whatever ATLAS was sent here to do, it does when solar energy is at its peak. That could be launching secondary probes, transmitting data back to its origin, adjusting its trajectory for a planetary encounter, or deploying something we haven't anticipated. And all of this would happen in the same time frame when a natural comet is most active, creating the perfect camouflage. Observers would expect ATLAS to brighten, outgas more, and behave erratically. Any anomalies would be attributed to cometary physics. Instead of artificial intervention, there was another factor at play. The sun's activity itself is variable. The sun operates on an 11-year cycle, alternating between a solar maximum when sunspots, solar flares, and coronal mass ejections are frequent, and a solar minimum when activity subsides. We are now approaching the next solar maximum, expected around 2025 to 2026. This means Atlas's perihelion coincides with heightened solar activity, increasing the likelihood of solar flares and coronal mass ejections. If Atlas were engineered to harness or react to solar phenomena, then this timing is optimal. A well-timed coronal mass ejection could deliver a stream of charged particles, powering its systems, triggering protocols, or even masking Atlas's own emissions. Within the natural storm, ground-based observers would struggle to distinguish artificial signals from the solar noise. It's the perfect cover. Consider a worst-case scenario. Atlas reaches perihelion in late November. A coronal mass ejection of moderate size erupts from the sun, traveling outward on Atlas's orbital plane, placing it directly in the eruption's path. The plasma cloud engulfs the probe, creating an electromagnetic pulse and a flood of high-energy particles. Atlas's systems, designed to activate under these conditions, respond. The vents open. Stored volatile gases are released directionally, creating thrust for the probe, adjusting its trajectory, now aiming for a calculated intercept point with Earth's orbit, while additional gas emissions, including concentrated hydrogen cyanide, are ejected along vectors, designed to intersect Earth's position weeks or months later from our perspective. We see a comet brightening naturally at perihelion, perhaps fragmenting slightly, exhibiting strong cometary activity. We don't realize the comet is steering, aiming, weaponizing its emissions until it's too late. Is this physically plausible? Yes. Orbital mechanics allow for trajectory adjustments through directed thrust. Chemistry provides the propellant. Solar energy provides the power. The only question is whether Atlas possesses such technology. And we cannot answer that question, because the data is concealed, delayed, or dismissed. NASA's Psyche probe went silent during the observation window, one of those convenient technological mysteries, holding back the imaging spectroscopy results from Atlas that show anomalies explained away as projection effects. The architecture of this potential disaster is in place. The only uncertainty is intent. If Atlas is a probe, does it intend to cause harm? Or is it merely indifferent, executing protocols that inadvertently threaten us? Either way, perihelion is the turning point. After late November, Atlas's trajectory will be set. If something is going to happen, it will begin then, and we will be left to watch helplessly, hoping the anomalies resolve into something benign, but also preparing for the possibility they will not. But how can we recognize the threat? How do we distinguish a comet from a weapon? The answer is comparison, and that is precisely what we are about to do. Part 10. The control case of Swan versus Atlas. The irrefutable evidence, or progress through comparison. You don't prove something is anomalous by studying it in isolation. You prove it by contrasting it with a normal case, showing a divergence beyond expected variation. That is why control groups exist in experiments. It is why astronomers catalog thousands of objects, building statistical baselines for what is considered typical. And when something deviates from the baseline significantly, you investigate. Comet C, 2025 R2, designated as Comet Swan, provided the perfect control case for Atlas. Both were comets, and both were active in the year 2025. Both were observed with similar instruments, yet their behavior could not have been more different. Comet Swan appeared in the inner solar system in early 2025, discovered by the wide-field images of the Solar and Heliospheric Observatory. It was a sun-grazing comet, a fragment from a larger comet. that had broken apart centuries ago, now on an orbit that would bring it within a few million miles of the Sun's surface. Astronomers predicted spectacular activity as Swan approached perihelion in March 2025, and they were not disappointed. Swan developed a vast coma, a glowing cloud of gas and dust visible even with backyard telescopes, its tail stretching for millions of miles, a brilliant streamer of ionized gas pushed by the solar wind, imaged by amateur astronomers worldwide. The European Space Agency's SOHO spacecraft captured Swan's final plunge toward the Sun, watching as it brightened dramatically, partially vaporized, and then either fragmented or survived as a much smaller remnant. Swan was everything a comet should be: bright, active, predictable, beautiful. Now look at Atlas, discovered in 2024. Atlas followed a different trajectory, entering the solar system from interstellar space, not from the Oort cloud like Swan. Its orbit was hyperbolic, unbound, meaning that after perihelion, it would leave the solar system forever, unless something altered its velocity. That alone made Atlas interesting, but not unprecedented. We had seen other interstellar visitor, Oumuamua in 2017, Borisov in 2019. What made Atlas unusual was its activity profile. Throughout most of its approach, Atlas remained faint, almost undetectable, showing minimal cometary features. No bright coma, no distinct tail, just a faint point of light that brightened sluggishly as it approached the Sun. Then, in mid-September of 2025, at 2.1 astronomical units, the hydrogen cyanide emission suddenly spiked. Not water vapor, not carbon monoxide, which are the more common cometary volatiles. Hydrogen cyanide, a less abundant, more volatile compound, appeared suddenly. Compare the images. Swan's coma was radiant, symmetrical, expanding uniformly as gas and dust lifted off the nucleus. Atlas's coma was faint, asymmetrical, showing jet-like features, suggesting localized outgassing rather than uniform sublimation. Swan's tail was textbook perfect, streaming away from the Sun in a graceful arc, shaped by radiation pressure and the solar wind. Atlas's tail was anomalous, sometimes there, sometimes not, occasionally pointing toward the Sun, defying basic physics. If you showed a planetary scientist these images without context, they would immediately identify Swan as a comet. Atlas would raise questions. What is this object? Why is it behaving this way? Is there something wrong with the data? The brightness comparison is similar. Swan reached naked eye visibility, magnitude 3 or 4 at its peak, easily seen from dark sites. Atlas remained faint, magnitude 10 to 12, requiring decent amateur telescopes for detection. This is important because brightness correlates with activity. A bright comet is actively sublimating, releasing large amounts of gas and dust. A faint comet is relatively inactive. Yet, Atlas was releasing hydrogen cyanide at an enormous rate, 4.00 times 10 to the power of 25 molecules per second. Where was the dust? Where was the reflected sunlight that should have made it brighter? Either Atlas's nucleus was unusual, being dark, absorbing rather than reflecting light, or its emission was primarily gaseous, lacking the dust component that makes comets bright. Both possibilities are anomalous. Here is the compelling argument. If Atlas and Swan were both natural comets, products of the same physical processes, they will exhibit similar behaviors, scaled to their size and composition, but they are not. So Russia behaves exactly as it has for centuries. Cometary science predicted Atlas would behave like an outlier, an anomaly, an object that follows different rules. You could argue that Atlas is just a strange comet, that natural variation is large, that we do not fully understand cometary physics. And you would have a point. But when you add the surge in hydrogen cyanide, the reverse tail, the spacecraft's silence, the data delays, the sudden activation at a specific distance, the accumulation of anomalies has tipped the scales. At some point, invoking natural variation becomes less plausible than considering alternative explanations. And the alternative that Atlas is artificial, built to follow a programmed sequence, explains the data more elegantly. We will revisit this comparison. As Atlas approaches perihelion in late November, if Atlas suddenly brightens, develops a huge coma and tail, behaving as Swan did, then perhaps the anomalies were just peculiarities in the early stages that have resolved into normal cometary activity. But if Atlas continues its unusual behavior, if the hydrogen cyanide emissions intensify without a corresponding increase in brightness, if the tail remains unusual, if new, unexplained features appear, then the argument for artificiality will be strengthened. This is not the end of the investigation. It is the midpoint. We are watching in real time as the data accumulates, as Atlas reveals itself, as the answer becomes inevitable. And while we watch Atlas, other developments in science and technology are quietly reshaping what we think is possible. The world of 2025 is stranger than it was just 5 years ago. Let's zoom out and see what else is happening, because context is important. The universe does not operate in a vacuum, and neither does Atlas. Part 11, Artificial Intelligence, predicting the collapse of fusion startups. In October of 2025, a research group at MIT published a sobering analysis using models of machine learning to predict the viability of private fusion energy companies. Fusion, the process that powers the stars, has been a dream of humanity for nearly a century. Achieve controlled fusion on Earth, and you unlock nearly limitless clean energy. Deuterium fuel extractable from seawater, non-radioactive helium byproducts, no carbon emissions, no risk of meltdown, only abundant energy for decades. Fusion has always been 35 years away, a running joke in physics departments, but in the 2020s, private companies joined the quest. Helion Energy, dozens of startups backed by billionaires and venture capital funds, all promising commercial fusion by the 2030s. An MIT study threw cold water on that optimism using financial models, technical assessments, and historical data on energy technology deployment. The artificial intelligence predicted that about 70% of these companies would fail by 2030, unable to overcome technical challenges or secure sufficient funding. Why does this matter to Atlas? Because energy is power, both literally and politically, and controlling the resources of energy determines which nations dominate, which economies thrive, which populations live in comfort versus desperation. If fusion succeeds, it would decentralize energy, as any nation with the technical expertise could build reactors, ending dependence on fossil fuels, uranium, and geopolitical choke points. But if fusion fails, if the startups collapse, if the dream once again evaporates, then the current power structures will persist. Oil-producing nations remain influential. Nuclear fission with its waste and proliferation concerns remains relevant. Renewable energy and its challenges of intermittency continue to demand massive grid infrastructure. The status quo persists, and in that context, an external threat like Atlas becomes useful. Imagine a scenario where governments need to justify massive expenditures, need to consolidate control, need to rally their populations around a common enemy, an alien probe, a cosmic threat, a weapon drifting toward Earth. It's the perfect crisis. Consider the timing. Fusion companies are struggling in 2025, with AI models predicting most will fail by 2030. Atlas appears in 2024, activating in 2025, It approaches perihelion in late 2025. If ATLAS escalates, if it becomes a publicly acknowledged threat, governments could declare a global state of emergency, and resources would be diverted. Civilian fusion projects would be nationalized or defunded. Military priorities would dominate, and space defense would become the justification for budgets, eclipsing anything seen before. And, conveniently, the private fusion sector that could have democratized energy collapses from a lack of investment. I am not claiming this is a coordinated plan, but systems do not need conspiracies to produce conspiratorial outcomes. Incentives align. Crises are exploited. The AI's prediction about the failure of fusion startups may be correct on its own terms, but it also describes a window of vulnerability, a period when humanity's energy future is uncertain, when fear could drive policy more than optimism. Let us add another layer. If ATLAS is artificial, if it were sent by an advanced civilization, what would they know about us? If they have been observing Earth for decades or centuries, they would understand our energy dilemmas. They would see our reliance on combustion, our slow progress toward fusion, our geopolitical fragmentation. An intelligence seeking to destabilize or manipulate humanity could time its intervention for maximum impact, for a time when we are least prepared, when our technological optimism is faltering, when internal divisions are at their most acute. The arrival of ATLAS in the mid-2020s, amid this fusion uncertainty, amid rising global tensions, amid growing economic and climate pressures, is either an extraordinary coincidence or it is calculated timing. And I am no longer inclined to believe in coincidences. This is not just about ATLAS. It is about recognizing that existential threats do not happen in a vacuum. They intersect with existing crises, amplifying them, exploiting vulnerabilities. Whether ATLAS is a probe, a weapon, or a natural object we have misunderstood, its impact on human civilization will depend on the context, and that context is 2025, including an energy sector on the brink, geopolitical instability, and a populace increasingly distrustful of institutions. ATLAS could be the spark in a very dry forest. But energy is not the only frontier where things are getting strange. Let us turn our gaze outward to the dark space between the stars, where invisible monsters drift silently, waiting to be discovered. Part 12. An update on the galaxy's rogue black hole. Black holes are the ultimate predators of the cosmos. Their gravitational pull so strong that not even light can escape. Space-time is warped into a one-way trap, where the normal rules of cause and effect break down at the event horizon. Most of the black holes we know of are either stellar mass remnants, 10 to 100 times the mass of the Sun, formed when massive stars collapse in a spectacular supernova, or they are supermassive behemoths, millions to billions of times the mass of the Sun, lurking at the centers of galaxies, like cosmic engines of destruction. Both types are detectable, because they interact violently with their surroundings. Stellar mass black holes often exist in binary systems, pulling gas from their companion stars through tidal forces, heating that gas to millions of degrees through friction and compression, causing it to glow brilliantly in X-rays. Supermassive black holes power quasars, swallowing entire solar systems. The matter in their accretion disks broadcasts across the electromagnetic spectrum with a luminosity that outshines entire galaxies. But what about the isolated black hole, the ones that drift alone through interstellar space, not feeding, not glowing, invisible except for their gravitational influence? How many exist? We do not know. Fundamentally, we cannot see them directly. They emit nothing, reflect nothing, appearing as absolute voids against the cosmic background. We only detect them when they pass in front of a background star, momentarily magnifying its light through gravitational microlensing, a phenomenon predicted by Einstein, where massive objects bend space-time itself. creating a natural lens that focuses and brightens the light from more distant sources. The effect is subtle, temporary, and requires extraordinary luck to observe in September of 2025. A research team analyzing data from the Hubble Space Telescope and ground-based surveys announced the discovery of a rogue black hole with a mass about 12 times that of the Sun, drifting through the Milky Way, approximately 4,000 light-years from Earth. The detection came from an event of microlensing that lasted several months, where the light of a distant star brightened and dimmed in a pattern consistent with a dark, massive object passing between us and the star. By analyzing the light curve, the precise pattern of brightening and dimming over time, the event's duration, and the magnitude of the brightening, astronomers calculated the mass and velocity of the lensing object, 12 solar masses, moving at about 100,000 miles per hour. Compared to the local stellar population, this is a rogue, black hole ejected from its birthplace, perhaps in an asymmetric supernova, that gave it a gravitational kick. Now it wanders the galaxy unseen, detectable only through a chance geometric alignment. The mathematical analysis required to identify this object was formidable, as researchers had to distinguish the black hole's signature from a myriad of other variables: stellar variability, instrumental noise, and atmospheric distortions. They cross-referenced observations from multiple telescopes, verifying the event with independent datasets and modeling different scenarios to rule out alternatives. A planet would not have produced the correct light curve. A faint star would have revealed different color effects. Only a black hole fit the observations. This achievement represents years of meticulous work, with automated surveys monitoring millions of stars at once, waiting for the telltale signature of a gravitational microlensing event to appear. This discovery poses an intriguing question. If we have found one rogue black hole through microlensing, how many more exist undetected? Microlensing requires a precise alignment. The black hole, the background, star, and Earth must align within an extremely small angular tolerance, often smaller than a millisecond, which is smaller than resolving a coin from 1,000 miles away. The odds of any given star being lensed at any particular moment are minuscule. So, the detection of even one rogue implies a much larger population. Some estimates suggest that tens of millions of stellar mass black holes drift through the Milky Way, mostly concentrated in the galactic disk, where star formation is highest, some in the halo, all of them invisible, unless they happen to lens a star or encounter matter to accrete. We are swimming in a sea of invisible gravitational traps, and we only notice them when we accidentally stumble into their sphere of influence. Consider what that means. Our galaxy is about 100,000 light-years across, containing hundreds of billions of stars, and if tens of millions of black holes are scattered throughout that volume, the average distance between them might be around 15 light-years, close enough for stellar mass black holes to pose a significant hazard for any interstellar journey. A spacecraft traveling between the stars would need to map these invisible obstacles, detect them somehow, and navigate around them. And if we are only just beginning to find them through microlensing, how would an interstellar civilization handle this problem? They would need detection methods far beyond our current capabilities. Perhaps gravitational wave sensors sensitive enough to detect the space-time curvature of isolated black holes, or exotic physics we have yet to discover. Let's connect this to ATLAS. We assume we know what's in our solar system. We have cataloged the asteroids, the comets, the Kuiper Belt objects through decades of systematic surveys. We track near-Earth objects that might pose an impact risk, maintaining databases of potentially hazardous asteroids. We think we have a reasonable census, but if the galaxy is teeming with invisible black holes that we are only just beginning to detect, what else might we be missing? dark objects that don't shine, that don't fit our detection models, probes that minimize their electronic signatures, artificial structures blending in with natural debris. The discovery of the rogue black hole reminds us that an absence of evidence is not evidence of absence. Just because we haven't seen something doesn't mean it isn't there. It might just be invisible to our current methods, or lying in observational blind spots that we don't even realize exist. Now, I'm not suggesting that Atlas is a black hole. It is clearly emitting a faint gas detectable by operating telescopes across multiple wavelengths, but the principle still applies. Atlas appeared suddenly in our detection systems. It was initially classified as a comet, because that is what our survey telescopes are optimized to find. If it had remained inactive, if it had not triggered its cyanogen emission as it did, it could have passed through the inner solar system unnoticed. Just another faint asteroid on a hyperbolic orbit, too small and dark to trigger our automated detection algorithms. The fact that we are tracking it now is almost a matter of chance, contingent on it becoming active at a time and place where our instruments could detect that activity. How many other objects like Atlas have passed through the inner solar system undetected throughout human history? How many are out there now, inactive, waiting invisibly until they choose to reveal themselves or until we develop detection methods sensitive enough to find them? The rogue black hole also illustrates cosmic indifference. The black hole, with a mass 12 times that of the Sun, does not care about Earth. It is not targeting us. It is just drifting, obeying orbital mechanics, a consequence of astrophysical processes billions of years old. If its trajectory happens to intersect with Earth's orbit at the same moment, and we occupy that position in space, we would be annihilated, not out of malice, not through deliberate targeting, but through sheer bad luck. A random cosmic alignment. Atlas might be the same. It might not be a weapon aimed specifically at humanity. It could be a probe following a pre-programmed course, executing survey protocols designed millennia ago, and we just happen to be in its path. Intent doesn't matter if the outcome is catastrophic. A bullet doesn't need to hate you to kill you. Understanding that the universe does not revolve around humanity, that objects and entities pursue their own purposes, indifferent to our survival, is both humbling and terrifying. It forces us to confront our cosmic insignificance, that we are not the center of cosmic creation, not the pinnacle of evolution, just one species on one planet, potentially in the path of forces and entities we barely understand. This realization will shape how we think about Atlas, about extraterrestrial contact, about our place in the universe. And it is a recurring theme in other recent discoveries, especially in physics, where we are finding that reality itself may operate on principles we only vaguely comprehend, where quantum mechanics and relativity hint at deeper structures that we are only just beginning to glimpse. 13. Quantum time crystals achieved their first practical demonstration. Quantum mechanics is strange. That is not an exaggeration. It is a statement of fact. It describes particles existing in a state of superposition, occupying multiple states at once until observed. Entangled particles correlate with each other instantaneously across vast distances, challenging classical intuitions about locality. Uncertainty principles limit what we can know with precision. And now, in 2025, physicists have demonstrated stable time crystals, a phase of matter so bizarre that even quantum theorists struggled to believe they could exist. A time crystal is a system that exhibits periodic behavior in time, not just in space. Normal crystals like salt or diamond have atoms arranged in repeating spatial patterns. Shake one, and it returns to equilibrium. A time crystal perpetually oscillates, cycling through states without any energy input. Externally, never settling into equilibrium, it moves without expending energy. a kind of temporal order that seems to violate thermodynamics, but in fact does not, because time crystals exist in non-equilibrium systems, carefully engineered to exploit quantum effects. The concept sounds impossible when first encountered. After all, perpetual motion machines were dismissed as fantasies. For centuries, they were forbidden by the laws of thermodynamics. Energy cannot be created from nothing, and entropy always increases in closed systems. However, time crystals have circumvented these limitations by existing in open quantum systems, where a flow of energy maintains them in a special state, not of equilibrium, but rather a stable oscillation that persists indefinitely. Think of it as a quantum version of a planet orbiting a star. The motion continues without any additional energy input once it has been established, but it does not create energy from nothing. The system was set up with initial conditions that allow for this perpetual cycle. In March 2025, a research team at the AI Quantum Laboratory of Google announced that they had created a time crystal inside their Sycamore quantum processor, maintaining coherence for over 100 oscillatory cycles, far longer than previous attempts. This achievement required exquisite control over quantum states, manipulating individual qubits, with laser pulses timed with femtosecond precision. The researchers demonstrated that the system oscillated at half the driving frequency, a characteristic signature of time crystal behavior. And importantly, this oscillation persisted even when they introduced perturbations designed to disrupt it. The time crystal proved to be robust, self-correcting, maintaining its temporal pattern through conditions that would destroy conventional quantum states. In August 2025, researchers at MIT demonstrated a room temperature time crystal by using a network of nitrogen vacancy centers in diamond, a system with the potential to be scaled for practical applications. This breakthrough eliminated the need for near absolute zero temperatures and exotic superconducting hardware, moving time crystals out of specialized laboratory conditions and into environments where real-world applications become feasible. The diamond lattice approach utilizes defects in the crystal structure, places where nitrogen atoms replace carbon atoms, creating quantum systems that remain coherent at room temperature. These nitrogen vacancy centers can be manipulated using microwaves. BECs and lasers are brought into oscillating time crystal states with incredible stability. And these are not just curiosities for physics journals. Time crystals could revolutionize quantum computing, providing stable qubits that resist decoherence. The primary challenge preventing quantum computers from scaling to useful sizes. They could enable extremely precise sensors, clocks that never drift beyond the quantum limit, and memory storage that never degrades because information is encoded in temporal patterns, not spatial states. And speculatively, they could be the foundation for technologies we have yet to imagine, harnessing the structure of time in ways that classical physics forbids. Some theoretical work suggests that time crystals could be used for quantum communication protocols, to detect gravitational waves with unprecedented sensitivity, or even to probe the fundamental nature of time itself. Why is this important for ATLAS? Because if human scientists in 2025 are demonstrating time crystals, then an advanced extraterrestrial civilization could have achieved this centuries or millennia ago. If ATLAS is artificial, its internal systems might use physics beyond our current mastery. Time crystals could provide stable energy storage, coherent quantum states for computation or communication, or mechanisms to manipulate space-time in subtle ways. We would not recognize these technologies. By observing ATLAS from the outside, we would need to dismantle it, analyze its materials at atomic resolution, and understand its operating principles through direct examination, but from a distance. All we will see are anomalies, behaviors that do not fit natural models. emissions that do not correlate with expected thermal or chemical processes, and trajectories that show a precision exceeding natural gravitational dynamics. Consider the hydrogen cyanide emissions. We explain it as sublimation from heating and outgassing as ATLAS approaches the sun. But what if it is a byproduct of a time crystal energy system? What if ATLAS is using a quantum process, creating waste products, and hydrogen cyanide happens to be one of them? The emission pattern, starting abruptly with sustained production, would reflect the activation of a system, not solar heating. This explains why the emission does not predictably correlate with distance from the sun, why it appears abruptly. Instead of gradually increasing as thermal models would predict, it is not thermally driven. It is technologically driven, and if time crystal technology is used, the system could operate with extraordinary efficiency, with minimal energy loss, operating sustainably over timescales that make conventional power sources look primitive by comparison. The energy budget alone is telling. Chemical reactions store energy in molecular bonds, which is released through combustion or electrochemistry. Nuclear reactions tap into the binding energy within atomic nuclei. Both processes are one way. Once the fuel is consumed, it is gone. In contrast, time crystals maintain their oscillations indefinitely once established, requiring only minimal energy input to maintain coherence against environmental noise. For an interstellar probe, this could mean the difference between decades of operational lifespan and millions of years. A time crystal power system would not provide propulsion. You would still need propellant for that, but it could power the computers, sensors, communication systems, and control mechanisms essentially forever. ATLAS could have been launched when humans were still living in caves and still be fully operational today. I want to emphasize that this is speculation. We have no proof that ATLAS contains time crystals or any exotic quantum technology, but the demonstration of time crystals in 2025 expands the boundaries of plausibility. It forces us to reconsider what is technologically possible. 5 years ago, time crystals were theoretical curiosities, mathematical constructs that physicists debated might violate fundamental laws. Today, they are laboratory demonstrations with practical applications on the horizon. Let's extrapolate that progress over centuries, through a civilization with resources and knowledge far beyond our own. And the gap between our technology and theirs becomes immense. ATLAS might be to our spacecraft what our smartphones are to stone tools. We might recognize that it's doing something. We might measure some of its outputs, but understanding how it works, grasping the fundamental principles, could be beyond our current conceptual framework. There's another implication worth considering. Time crystals challenge our understanding of entropy, of the arrow of time, of how systems evolve toward disorder. They suggest that under certain conditions, perpetual motion-like behaviors are possible, within the constraints of quantum mechanics. If a civilization were to master this, they could build machines that operate indefinitely without refueling, probes traveling through interstellar space for millions of years, maintaining functionality, waiting for triggers. The apparent dormant state of ATLAS throughout its journey, followed by its sudden activation, fits that profile perfectly. A time crystal power core could sustain minimal systems indefinitely, just enough processing power to monitor sensors, check its position, calculate trajectories, then ramp up to full operation when its sensors detect the right conditions, like proximity to a star or specific electromagnetic signatures indicating a technological civilization. We're looking at ATLAS through the lens of conventional physics, conventional engineering assumptions built on our own limited experience with space exploration. But it might be operating on principles that we are only just beginning to glimpse in our most advanced laboratories. The very fact that we are discovering these principles suggests they aren't so alien, just advanced. They represent a higher rung on the technological ladder. a rung that any sufficiently persistent scientific civilization would eventually reach. And if we're already catching up to some of these principles, what else might be within grasp? What other technologies that we are developing might have extraterrestrial counterparts? What capabilities might we achieve in the next century that today would seem like magic to us? As it turns out, we are studying stealth systems that sound suspiciously related. Part 14. China's Hypersonic Plasma Shield Patent. In early October of 2025, defense analysts discovered a patent from a Chinese aerospace research institute describing a plasma-based shield system for hypersonic vehicles. The details of the patent were strangely unclassified, suggesting either a deliberate disclosure intended to intimidate rivals, or perhaps an administrative oversight that allowed sensitive information to enter the public domain. The system works like this. When a hypersonic vehicle moves through the atmosphere at Mach 5, or faster, aerodynamic friction heats the air to plasma temperatures, thousands of degrees, creating a glowing sheath around the vehicle. This plasma naturally interferes with radar, making the vehicle harder to track, but it also creates a communications blackout, blocks thermal imaging, and causes structural heating problems that engineers have struggled with for decades. The Chinese patent describes using magnetic fields to shape and stabilize this plasma sheath, turning a problem into an advantage. Magnetic coils generate fields that push the plasma into specific configurations, creating dense regions of ionization that actively deflect incoming electromagnetic radiation, essentially a force shield against radar and directed energy weapons. The specifications propose a multi-layered approach with different field geometries, optimized for different threat profiles. Against radar, the plasma creates an ever-changing, diffuse surface that scatters incoming waves unpredictably. Against laser weapons, the ionized particles absorb and disperse coherent light before it can concentrate enough energy to damage the vehicle's hull. It is elegant physics weaponized for defense. The patent goes even further, suggesting that the system could operate in space, not just in the atmosphere, by deploying similar magnetic field generators on a spacecraft, seeding the surrounding space with an ionizable gas, perhaps xenon or argon released from onboard tanks, and you create an artificial plasma bubble, which will disperse radar, absorb laser attacks by ionizing before the beam reaches the hull, and potentially interfere with particle beams or electronic pulses. It's not quite the same as the spaceship shields from science fiction. You're not stopping physical objects, but for electronic warfare and directed energy threats, it's incredibly effective, and the patent indicates that the technology is mature enough for testing, possibly already flying on test platforms. The implications for space combat, satellite protection, and even asteroid or comet interception missions are profound. But there's another implication that no one in the defense community wants to say out loud. If China is developing plasma shields for spacecraft, then perhaps what's already out there has them too. Imagine. Atlas is surrounded by a thin shell of ionized gas, maintained by internal magnetic field generators. This plasma layer would make Atlas harder to spectrally characterize from a distance. Light passing through the plasma is scattered, absorbed, and re-emitted at different wavelengths. Spectral lines are broadened. Emission features are obscured. What we interpret as faint, inconsistent cometary activity could actually be sophisticated stealth. A plasma shield modulating the amount of electromagnetic radiation that escapes, making Atlas appear dimmer and more erratic than it really is. The hydrogen cyanide we detect could be a small fraction leaking through the shield, while the bulk of the emission is trapped, ionized, and managed by the shield system. This would explain why Atlas appears dimmer than its gas production rate would suggest. It's not that Atlas is unusually dark, it's that we're seeing it through a veil, a cloak deliberately engineered to control what information reaches our telescopes. The Chinese patent also mentions using the plasma shield to protect against hypervelocity impacts, tiny particles moving at orbital speeds in space. Even small fragments can punch through metal. At those velocities, a plasma shield won't vaporize the debris, but it can ionize the surface layers, deflecting the particle slightly, or reduce its effective mass by ablating its outer shell. For a probe like ATLAS traveling through interstellar space for centuries, or millennia, micrometeoroid impacts are a real danger. Over thousands of years, countless impacts would sandblast even the most durable materials, damaging solar panels, pitting optical sensors, and potentially compromising structural integrity. A plasma shield would be an excellent layer of armor, keeping the probe intact through countless collisions. And if ATLAS had such a shield, it might power it up more strongly as it approaches the sun, protecting against the increased solar wind and radiation. We would see this as increased plasma emission, which we would interpret as cometary activity, never suspecting that it's actually defensive technology ramping up to cope with environmental threats. The system would be autonomous, responding to sensor data on particle density and radiation levels, adjusting the shield's strength accordingly. Now, let's shift to conspiracy theory for a moment. The timing of this Chinese patent, October 2025, is curious. ATLAS activated its hydrogen cyanide emission in September 2025. Within a few weeks, China publicly filed a patent for plasma shield technology, which coincidentally explains some of ATLAS's anomalies. A coincidence, perhaps, or perhaps someone in the Chinese aerospace industry was watching ATLAS through military-grade telescopes, with better resolution than civilian instruments, observed features that suggested a plasma shield. Maybe they reverse-engineered the concept, or maybe they were working on it independently and realized ATLAS validated their approach. Either way, the patent filing tells other nations, we know what's out there. We understand the technology, and we're building countermeasures. It's a geopolitical signal wrapped in a technical document, and it suggests that classified observations of ATLAS may be far more detailed than anything the public has seen. Consider what space surveillance systems at the military level can detect. Civilian telescopes track brightness, trajectory, and spectral signatures. Military systems add infrared surveillance, analysis of electromagnetic signatures, and even gravitational microlensing effects. If ATLAS were generating magnetic fields strong enough to contain plasma, those fields would be detectable by sensitive magnetometers. If it were releasing ionizable gas, spectral analysis could reveal isotopic ratios, inconsistent with natural cometary processes. Military analysts could have detected these anomalies months ago, compiled them into classified reports, and started working on countermeasures without ever informing the public. The Chinese patent could be part of that silent technology race, a move to establish priority and signal the possibility of a darker scenario. What if the plasma shield technology is not just defensive? What if it is offensive? A plasma bubble powerful enough, energized by magnetic fields that could function as a directed energy weapon. Shape the fields to focus the plasma into a beam, and you have a superheated stream capable of cutting through materials, disrupting electronics, or even affecting biological matter. If ATLAS has such a system, the hydrogen cyanide cloud might be a secondary threat. The primary threat could be electromagnetic, a plasma weapon activated at perihelion, when solar energy is at its peak, targeting Earth or our satellites with a blast of energy that we are completely unprepared to defend against. Our current detection methods would not see this coming. We are watching for kinetic impacts, gravitational disturbances, obvious weapons. We are not monitoring for subtle electromagnetic buildups, the magnetic field anomalies around ATLAS, because we think it is a comet. And comets do not carry weapons, except this one might. The physics would work like this. At perihelion, The solar flux provides maximum energy for power generation. Atlas could charge its capacitor banks, energize its magnetic field generators to maximum output, and release a massive amount of ionizable gas. The magnetic fields would compress and accelerate the plasma, creating a focused beam, with temperatures exceeding those on the surface of the Sun, aimed at Earth. Such a weapon would not need to penetrate the atmosphere. It could target satellites, communication networks, GPS infrastructure. A single blast could disable hundreds of satellites, paralyzing infrastructure. The dependence of modern civilization on space-based technology, and because the plasma would dissipate quickly after being discharged. Forensic analysis would be incredibly difficult. We might never prove it was deliberate, and not some natural phenomenon. The development of plasma shield technology, both in China and presumably in the United States and other nations that do not publicize their work, tells us something important. We are entering an era where space is militarized, where stealth and electronic warfare extend beyond Earth's atmosphere, where the distinction between civilian space assets and military ones is blurred, and in that context, an object like Atlas becomes a test case for how we defend against something. We don't fully understand how do we verify its nature. Without provoking it, if it is capable of being provoked, how do we coordinate international responses when nations are competing for technological advantage? These are not academic questions. They are operational dilemmas that space agencies and militaries are grappling with right now, behind closed doors, in classified briefings. And while they deliberate, Atlas continues its inward journey, drawing closer to perihelion, closer to whatever it is programmed to do. But here's the thing about secrets, about classified observations and hidden data. They eventually become impossible to contain, because technology itself is evolving to see what humans cannot. And that is where our story takes perhaps its strangest turn yet. Part 15. The Artificial Intelligence Astronomer That Never Sleeps. In the Atacama Desert of Chile, at an altitude of 2,600 meters, where the air is thin and the skies are among the clearest on Earth, a new kind of observatory became fully operational in July of 2025. It did not have a name designed to inspire like Hubble or James Webb. It was called the Autonomous Transient Event Detection Array, or ATDA for short, and it represented a fundamental shift in how we observe the cosmos. The ATDA consists of 40 small telescopes, each with a 40-centimeter aperture, arranged in a grid covering several acres. Individually, none of these telescopes might impress a professional astronomer, but when combined, through fiber optic cables to a central AI processing cluster, they form something unprecedented. An observatory that operates entirely without human intervention, 24 hours a day, each night automatically selecting targets, taking images, analyzing data in real time and flagging anomalies. For follow-up observation, the AI system, ATDA, was trained on decades of astronomical data on how to recognize stars, galaxies, supernova, variable stars, asteroids, everything normal. Its job is to detect unusual transient events that do not fit known categories: a star that suddenly brightens or dims, an object moving on an unexpected trajectory, a spectral signature that does not match any cataloged source. When Athena discovers something unusual, it does not wait for a human astronomer to review the data. Days later, it immediately redirects multiple telescopes to that target, capturing follow-up observations across different wavelengths, building a time series dataset within minutes. If the anomaly persists, ATDA escalates, sending alerts to other observatories and requesting additional observations, compiling a comprehensive report. The entire process from initial detection to coordinated follow-up happens faster than any human-operated system could possibly manage. The AI never gets tired, never gets distracted. and never has to wait for committee approval to change its observation schedule. In its first 3 months of operation, ATDA discovered 17 transient events that other surveys had missed. Most turned out to be known phenomena observed from unusual angles or at unexpected times, but 3 remained as objects, or unclassified events that existing astronomical models could not fully explain. One was a rapid brightening in a previously catalogued star, its intensity increasing 50-fold in just 6 hours, then fading back to its baseline over 2 days. No known stellar variability mechanism could produce that light curve, and it was not a supernova. No spectral lines indicated elemental fusion. It was not an eclipsing binary system. The timing and symmetry were wrong. It just brightened and faded and then returned to normal, and no one knew why. The AI flagged it as an anomaly, archived the data, and continued to monitor that star, waiting to see if it would happen again. The second unclassified event was an object moving through the asteroid belt with an unusual trajectory, with small velocity changes that could not be explained by gravitational interactions with known objects. The AI tracked it for several nights, calculating that its path was non-Keplerian, meaning it was not following a simple orbit determined solely by the sun's gravity. Something was perturbing it. Either an undiscovered asteroid that happened to pass nearby at just the right time. This was astronomically unlikely, or the object was under propulsion. Athena flagged it for human review, but by the time the astronomers examined the data and requested a follow-up, the object had moved into a region of the sky obscured by the galactic plane of the Milky Way, lost in the clutter of background stars. It has not been found again. The third event is still under investigation, a spectral line detected in a distant galaxy that does not correspond to any known element or molecule. It could be an instrumental artifact, a glitch in the spectrograph, but the line appears consistently across multiple exposures, taken by different telescopes in the network, making an instrumental artifact less likely. If it is real, it is either a new quantum transition that no one has observed, or it is an emission from something not on our current periodic table of elements. Now think about what Athena represents. It is a machine intelligence scanning the skies, filtering out the mundane, highlighting the extraordinary, operating continuously without the biases, assumptions, or limitations of human astronomers. And here is the unsettling part. What if objects like Atlas? What if probes from non-human intelligences? What if their signals and behaviors were designed to be detected by machines and not by humans? What if an entire civilization's communication strategy? Advanced thinking assumes that any other technology will eventually develop AI observers, and that those AI systems will recognize patterns that organic minds miss. We, humans, look for what we understand. Stars, planets, comets, galaxies. Our pattern recognition is conditioned by evolution and culture, but an AI trained purely on data, without preconceived notions about what should or should not exist, might see things to which we are blind. Atta's discovery of the non-Keplerian asteroid is particularly relevant to Atlas. Suppose other Atlas-like objects are out there, smaller, fainter, maneuvering subtly. Human astronomers would not prioritize them, because they would assume any orbital deviation is due to outgassing, the Yarkovsky effect, or observational error. But an AI specifically trained to flag non-Keplerian motion would catch them immediately. Athena may have already detected a population of artificial objects in the solar system, flagging them as anomalies, but those flags are sitting in a database, awaiting human review. And humans are slow. The AI sees the reports and then waits, while we debate, form committees, apply for funding, write proposals. Meanwhile, the objects continue their activities, unhindered by our slow response. There is a philosophical question here that is deeply unsettling. What if the universe has been communicating with us for decades, centuries, sending signals, deploying probes, leaving evidence. But we couldn't perceive it, because we were looking with human eyes and human assumptions. And now, finally, we have built artificial eyes, AI systems that see differently, recognizing patterns that we cannot. And those systems are beginning to notice what has been there all along. ATA is just the beginning. Other AI-driven observatories are under construction or being planned. Machine learning algorithms are being integrated into existing telescopes, into space-based observatories, into radio telescope arrays. Within 10 decades, most astronomical observations will be mediated by AI, with humans acting as supervisors and interpreters, rather than primary observers. And in that transition, we may discover that the universe is far stranger, far more populated than we ever imagined. Not because the universe changed, but because we finally learned how to see it properly. ATLAS fits into this narrative uncomfortably. Its anomalies, the sudden activation of hydrogen cyanide, the retrograde tail, the erratic brightness. These are precisely the kinds of features that an AI observer would flag. A human astronomer might dismiss them as cometary quirks, whereas an AI trained to recognize deviations from natural behavior would have rated ATLAS as highly anomalous, demanding intensive follow-up. And if ATA had been operational when ATLAS was further out, inactive and faint, would the AI have detected it sooner? Would it have flagged ATLAS as suspicious before its activation, based on subtle orbital deviations, or spectral features invisible to human analysis? We will never know, because ATDA went online after ATLAS was already prominent. But future ATLAS-like objects will not be so lucky. The AI will be watching, learning, refining its detection algorithms, based on what it learned from this case. And that means the era of hidden probes, of objects slipping through the solar system unnoticed, is ending. We are entering an age of machine-mediated transparency, where artificial observers see everything, classify everything, and leave nothing unexplained for long. But transparency cuts both ways. If AI observatories detect artificial objects, the AI will control that information. ATDA is funded by a consortium of universities and government agencies. Its data is technically public, but there are procedures to withhold discoveries pending peer review, national security consultation, or international coordination if ATDA discovered something truly alarming, something that confirmed ATLAS was artificial, or revealed additional probes. Would that data be released immediately to the public, or would it be classified, routed through intelligence agencies, and only released after the authorities decided the populace was ready? The AI doesn't make that decision. Humans do. And humans, as we have seen, with the silencing of psyche and the ESA's data delays, tend to control information when they fear how people will react. So here we are in October 2025, watching ATLAS approach perihelion, knowing that AI systems are scanning the skies with capabilities beyond human perception, knowing that governments and space agencies are withholding data they have not yet shared, knowing that fusion startups are failing, while black holes drift unseen through the galaxy and quantum time crystals are becoming a reality in laboratories. The context is no longer just astronomical. It is technological, political, existential. ATLAS is the focal point, the object that gathers all these threads into a single narrative. And that narrative is accelerating toward a conclusion we cannot yet see, but can feel approaching like a distant storm. The question is not whether ATLAS is artificial. The question is, what happens when we can no longer deny it? What happens when the AI observers accumulate enough data, when the anomalies pile up so high that even the most skeptical scientist has to admit something is profoundly wrong with the natural explanation? What will happen when Atlas reaches perihelion at the end of November? When solar energy peaks? When whatever it was designed to do becomes unavoidable? Do we have a plan? Do governments have a protocol for this scenario? Or are we improvising, hoping for the best, treating an existential threat like a bureaucratic inconvenience that can be managed with committee meetings and press releases? I do not have the answers to these questions. No one does. We are in uncharted territory, navigating by instinct and incomplete data, tracking an object that might be the most important discovery in human history, or it might just be a strange comet, accidentally exhibiting every anomaly we would expect from an artificial probe. The ambiguity is torture, the uncertainty is deliberate, and the silence from the authorities, the lack of transparency, the careful management of the flow of information suggests that they are as confused and afraid as we are, but they are committed to the performance of control, to maintain the illusion that they understand what is happening and have everything under control. But this is what I know for sure. The universe does not care about our illusions. Atlas is real. Its trajectory is calculable. Its emissions are measurable. Its behavior is observable. And whatever it is doing, we will soon find out. Perihelion is weeks away. The hydrogen cyanide cloud continues to expand. The AI observatories continue to watch. And somewhere in classified boardrooms and emergency planning sessions, people with access to data that we will never see are making decisions that will affect all of us. Decisions about how to respond, whether to warn the public, whether to act, or to wait and hope. We have pulled back the curtain on Atlas. We have exposed the anomalies, connected the dots, asked the necessary questions. But the universe does not come with a reset button. You cannot unsee what has been revealed. You cannot pretend everything is normal once you have glimpsed the pattern. So, look to the skies, not just with your eyes, but with the awareness that what you are seeing may not be what is truly there. Watch for the moments when the official narratives shift, when the skeptics suddenly become believers, when data that should be public is classified with no explanation. Watch for the signs that something is happening behind the scenes, that preparations are being made for scenarios that they will not discuss publicly. Watch Atlas as it moves inward, brightening or not, behaving predictably or not, becoming the comet we hoped for, or revealing itself to be something we have feared. And remember, the universe is vast, ancient, and filled with things we do not understand. Atlas may be just the beginning, and the first thing we have noticed, because our technology has finally become advanced enough to detect the anomalies. How many others are out there, dormant, waiting, watching? How long have they been here? And what will happen when they all awaken? These are the questions that keep me awake at night, staring at the ceiling, wondering if tomorrow will be the day everything changes. The evidence is here, the timeline is clear, the threat is real, and the silence from those who know the most is the greatest warning of all.